or one sample population proportion, or called a one prop interval. So as always, you're going to do the same steps you always do. You're going to state your random variable and parameter. You're going to state and check your conditions. Conditions are the same as in a hypothesis test for one proportion, and the checks are exactly the same. Calculations is your next step. Calculations are basically the same. You've actually already done it. You just have to look for the confidence interval instead of um, the hypothesis test information. Then you have statistical interpretation and a real-world interpretation. So let's go through the problem here. So we're finding a confidence interval for the following problem. A study by Hill Harris X poll was conducted online among 1,000 voters, and they found that 615 say they would definitely vote in the 2020 election. I want you to estimate the portion of voters who will vote in the 2020 election. Use a 95% confidence interval. Now I realize that the election is well gone, but it was so we could look back to see what it really was, but this is just a chance to see how this works. All right, so first step of every problem is you're going to state the random variable and parameter. So in this case, my variable is the number of voters who will vote in the 2020 election. And your parameter is the proportion of voters who will vote in the 2020 election. Then we're going to state and check the conditions. So the first one is that you have to have a random sample of 1,000 voters. Likelihood to vote is taken. So that's the stating part. So we're going to state that. That's what you want to have happen. The check, we don't actually know for sure, but we're assuming that this company, who's a pretty reputable company, probably took a good poll. We're not positive, so we're not really sure this is true. We're going to assume it is, but remember, assuming something can be a problem. But we're going to assume it's going to be true because of the reputation this company has. But we're not positive, so it may not be true. The next thing is to state that the properties of a binomial experiment are satisfied. And we're going to check this. So there is a fixed number of trials. There are 1,000 voters asked. The voters' likelihood is independent of the other voters. There are two outcomes. Will or will not vote. And the last one is the probability is the same. So this is met. The next one, or the last one, I should say, because there's only three in this case, is that the sampling distribution of the sample proportion can be approximated with a normal distribution I'm going to check this. The problem with the check on this one is that we don't know what the P is. So normally you do N times P. We don't know what P is because that's what we're trying to find. We're trying to estimate that. So we're not exactly sure what that is. But we did notice we have 1,000 voters. So N times P will actually give us 1,000. Actually, it'll give us, sorry, it will not give us 1,000. It'll give us 615 as an estimate. And N times Q is equal to 1,000 minus the 615. Both of these numbers are more than 5, so we're good. All right, now we get to our calculations. So we'll insert our R chunk. We're doing a prop dot test. We had 615 as our X value, as the number we actually found out of the 1,000 we counted from. We're not going to put a P in there because we don't actually know what P is. We are going to do a conf dot level, and that is equal to 95. So you need to put in 0.95. It is going to default to 0.95, so if you forget to put this in, it will default to that, but it's always a nice idea to put it in just to make sure you did it. So here's our answer. Looking at this, we don't need, this tells us how many we put in. We knew that. We don't need this information because we're not doing hypothesis tests. We need this 95% confidence interval, and there it is. So we're saying that P is between these two values. That's sample proportion. So now we can get to our statistical interpretation. And that says that we are, or I am, 95% confident that the interval 0.58 less than proportion less than 0.65 contains the true proportion of voters likely to vote. So notice with statistical interpretation, I'm not 95% confident that the interval, that the proportions in that interval. I'm 95% confident I captured that true value. I caught that interval. Now we can go to the real world. This is what you're going to tell people. And that is, and again, what we were trying to estimate was the proportion of voters who will vote in the 2020 election. So we are going to say that our real world interpretation is the proportion of voters who will vote in the 2020 election is between 58% and 64.5%. You can also do this if you'd rather give it that way. You could give it as 61% plus and minus. That would be about 3%. So you could also do it that way if you wanted to. And we probably should call that 58.4%. So that plus or minus 3% is known as the margin of error. Okay.